Getting hot here. All right, welcome everyone. So we're going to be taking a look at, I call this like mixed review. It says field test, whatever you want to call it. So we'll start with the multiple choice. Number one, I can't really hide number two, so I'm going to go like this so we're not distracted by it. Just number one, Roman numeral one, our favorite. These take a little bit of reading and double checking that you're not misinterpreting anything. So Mr. Rice asked his class to determine which statements were correct, or is correct if, well, I guess it has to be more than one. So which statements were correct? 1 and 3, 2 and 3, etc. So go through these. What I like to do as a tip is put it next to the Roman numerals like a check or an X, and then look for the choice that has those two checks. Go ahead. Okay, so obviously this is testing rational versus irrational ideas, knowing some vocab as well, sum, quotient, difference, product. We have our four key operations. Anyone want to share out, what did they get for this? What did they get for number one? Choice B, we're getting, okay, so 2 and 3. Let's go through them. This is how you have to really do it. Read each Roman numeral separately. The sum of radical 36, which let's just clean that up, is just 6, basically, right? And 2 rad 6 is rational. So we have a rational number plus something that can't be simplified any further. That's always going to be irrational. The quotient of 3 radical 300 and 12, radical 12, is rational. So quotient means to divide. So radical 300 divided by radical 12, with the 3 kind of out front. Just like with multiplying, you're allowed to divide radicals. So I could actually say like 300 divided by 12 and put that in a new radical. And that works out nicely because that's just 25, which is, we know is obviously just 5. So this works out to 15. That's true. Looks ugly. 2 irrational numbers actually worked out nicely here, conveniently to 15, which is rational. The difference of 2 radical 49, which is 7, so 2 times 7, 14, and radical 9, which is just 3, is rational. Yeah, that makes sense. Those are both nice numbers that are just kind of in disguise. And the product, multiplying, of radical 25 and radical 8, we can multiply there, but it doesn't help us because we just get radical 200. Which, yeah, you can do things with that, but it's always, we could pull out a 10. You're always going to be stuck with some radical there. So no good for 4. So 2 and 3 are good. So choice B is what we're looking at. Choice B, very good. Questions with that one? All right, exponential growth and decay. We focused a lot about this, and I know these are so tightly bunched together, like you're going to want to be distracted every time we do one question, but try to just focus on the one we're doing. In number 2, we focused a lot about like, what is the percent? What does this mean? What does that mean? Be careful here. So which of the following statements regarding growth or decay, given the example, is accurate? Take a minute to read this one over. Okay, any answers? What do we think? Yeah, choice C. So let's go through them again. And C is the answer, but let's go through them just to see what's wrong with each one. In choice A, the principal amount, which is the number in front. So in this case, they just left it as P. The principal amount, I also think that's spelled wrong. Principal amount of money is increasing at a 25% rate. What is the rate in A? What is the actual rate in A if it's not 25%? What should the rate have been in A? Yeah, 2.5%. So that's not good. In B, is the rate 52%? No, same, even worse there. That's really what? 0.52. 0.52. Yeah, that's really off. But I can kind of see that because 0.52%, maybe they then make it 52%. But in C, yeah, it's what's missing from it being 1. 1.00 would be 100%. So if it's 0.86 or 86%, that means that it's decaying at a rate of 14%. It's what's missing from it being full. So that's correct. In D, this is common. I could see someone putting D, they just see 68. They go, oh, it's 68% decay. We know it's decay because it's less than 1, but you're messing up the percent. Here it should be 32%. Very good. Okay, good question based on what we talked about just the other day. All right, and I like this one because sometimes when we give literal equations, it's kind of just like, hey, here's the area formula, solve for H. This one is not a direct one. We did one like this when it was like heart rate or blood flow or something. It was kind of in the same realm of like, all right, it's not as straight up as a normal one. With if I just said, hey, solve this equation for D, that would be a lot easier, right? But this one is saying, which one is transformed correct? Excuse me, incorrect. So we can't even answer this right off the bat. First of all, does anyone recognize this formula? Does anyone recognize the formula as a side note? Should look familiar. Anyone recognize the formula? No. Has to do with sequences, but not recursive. It's the arithmetic explicit formula. Yeah, it's the arithmetic explicit. Explicit. The recursive is the common sense one, like A1 equals A sub n plus 1 equals A sub n plus D. This is the explicit arithmetic rule. Okay. So which of these is incorrect? So I guess let's analyze the choices. We see that it's only solved for D or N. So, I mean, we could solve it for D, hopefully see an error there, or if not, we have to move on to N. So let's just solve it for D first. I'm going to give myself some space. I never use these. What are they called? Stickies. Wait, where are the things? Stickies. Okay, so that doesn't work. Okay, so I'm going to solve it for D. I'm going to rewrite the explicit. And let's solve it for D. So the first thing that I would do is get rid of the A sub 1. Let's subtract A sub 1 from both sides. Okay, we're getting there. And now what to solve for D? Do I want to distribute D here? Do I want to distribute? No, I don't want to distribute D to make it more confusing. Yeah, we could just divide by n minus 1 and call it a day. So let's divide both sides by n minus 1, and that's our formula. Okay, so be careful. Roman numeral 1 is like the answer we have right there. Oh, yeah, okay, I forgot about this. Now, this is a good one. Roman numeral 2, you're like, all right, that's what it should look like. It's not 2. 2 is actually correct as well. So what can you do to get, what could you do? How do I want to phrase this? Yeah, so it has to do with kind of manipulate. Let's do this instead. Let's do this. Let's do this. Let's solve for n. So let's rewrite. We all know Roman numeral 1 is out here, right? That's the technical answer. We're not sure about 2. Let's just say we're not sure about Roman numeral 2. Looks kind of weird. For Roman numeral 3 and 4, we see that it's n equals. So let's take this and now solve for n. So I'm going to start the same way. I'm going to start off by getting rid of a1. Subtract a1 from both sides. Now what? So this is where it's going to change. We're not solving for D anymore. Now we're solving for n. What would you do here to solve for n? I wouldn't want to distribute Abram. Yeah, I would divide by D. Let's get D out of the picture here. Distributing is only going to make it like it's not going to help our case. So we get this. And now there's one more move left. Yeah, and then just add 1. So a sub n minus a sub 1 over d plus 1 happens kind of separate from that quotient, happens separate. All right, and let's see. Where's like the exact match for that one? Yeah, Roman numeral 4, no good. All right, so 2 and 3 are kind of weird because you're like, how could they be different? But it's like a manipulation of this correct one. It's a manipulation of this correct one. So it's between 2 and 3, right? Which one got manipulated correctly here? So let's work. We have n up here. Let's work with it. So it might be a good idea rather than just kind of like randomly guessing at things. Look at what n is equal to here. Is there some way we can write it like that? This is hard to explain, but I'll try my best. So we see this part. What's different here? We see this same part, and then we saw like in ours, it should have been a plus 1. However, if we separate it, I'm going to rewrite d just separate it a little bit, and hopefully this will make sense. This is a difficult one to explain, but so I'm separating it like such. Okay? In other words, d over d, they have a common denominator. At some point, these got added together. Do we see how Roman numeral 3 and Roman numeral 4 are actually saying the same thing? So what they did was they treated 1 as like a d over d, which is the same as saying plus 1. So 3 was actually done correctly. It was 4. It was Roman numeral 2 that's going to be the incorrect one here. 2 was close. 2 had a similar idea of like, oh, what if you separated this, but we can't separate it that way. Is this on the Regents? This wasn't I forget where I got this from. So sorry, the answer here is 2. 2 is incorrect. Yeah, I forgot where I got this from. No, yeah, I meant the answer. Well, let me put it this way. Do you guys remember doing like the blood flow one? I forget what year that was from. It was like heart rate or blood flow or something. Kind of like that. This was just a more difficult version of that. I think we would all cross off 1 and 4. I'd like to think we could do that. That wasn't too crazy. And then deciding between 2 and 3 was the idea of like manipulating, writing it slightly different. Like in Roman numeral 3, seeing that d over d is the same as that plus 1. Yeah, Anthony. Well, wasn't it real? I think it's a real formula. Okay, I'm going to skip number 4 because hopefully you don't have to remember too much, but this was on the mock Regents that you guys did. The one thing that I'll add about this, because some people, this was like our worst question on the mock. It said basically convert centimeters per day into, what was it? Inches per hour. So we're not going to do the exact same question again. I think it's the exact same number. People had no idea to do this, and we are going to do a review lesson on this topic. The whole thing was just looking at the reference sheet. If you look at any Regents, there's a little like formula sheet, and I know it's more of like a science topic, but there's conversions for everything. There's something that says 1 mile equals 5280 feet, 5,280 feet. 1 inch equals this how many centimeters. So once you pulled out that conversion, you set up a proportion and solved. And it was choice A, I think, right? You also had to convert days into hours by dividing by 24, but that was all covered in the mock Regents video if you want to check that out. But something to talk about. All right, let's get back to 5. Yeah, I know 3 was scared. Don't get too scared by 3, but that's a good question. I like questions like that. All right, for 5, Luke is solving the equation, that should say, x squared plus 10x minus 3 by CTS, complete and square. Using this method, which procedure would not be used? Take a minute to read it. Don't type anything in the chat. Which procedure would not be used ever, like in the problem? Take a minute. Don't write anything yet. That's just the equation. Yeah, the centimeter one was on the June 2019, I believe. It was like the last, I think it was 24. 23 or 24. Not yet. Take 1 minute. Ryan, what is Ryan's video? It's like a banana. Is it actually you? Like if you wave, does the thing wave, or it's just like a GIF? Yeah, like if you blink or smile, does the thing wave? Does it wave if you wave? All right, guys, type your answers for 5 in the chat. Type your answers for 5 in the chat. Yeah, what is B? We never do that. Double 10 and add it to both sides? No. Do we add 3 to both sides? Yeah. I like to get rid of the number, right? Do we eventually express the trinomial as a perfect square? In other words, like we do this? Yeah, that's like the main part of CTS. Do we take the square root? Yeah, that's also the main part. So there's no part where you're doubling 10 and adding it. If anything, they were probably mistaking it for like cut 10 in half and square it. That's like probably what they were getting at here. So like the magic number in this problem would be 25, right? But we don't double it. Mr. Thanos. Mr. Thanos has just been hired as the president of Avengers Industries. He has 4 choices in terms of how he collects his salary for 2 years. Which plan should he choose in order to have the highest salary in his 8th year? So which choice will give him the highest salary in year 8? Take a minute or so to read this question. No, some of these are made up. Well, none of them would have made sense. Why would Thanos work for any of these people? So what's the strategy you're doing for this? Some of these are like scary looking. Calc, yeah, y equals. Go to second graph and just look for 8. Which one has the highest 8 value? Maybe do it in order so you can tell which one's which. I'm going to do the same. Remember to type X. There's still people that type like T into their calculator when they do this. Type X. Your calculator won't know what T is. Square root. For C of T, that's all under the radical. So it's radical 400x all underneath. What kind of function is d of t? That's a quadratic. It's not in vertex form or standard form. It's kind of like in its own thing. Which one has the highest salary in year 8? Not total, but highest salary just in year 8. I'm assuming this is in like thousands of dollars or something. Could use some common sense here. We have like exponential, linear, square root, or quadratic. Which one had the highest salary in year 8? What do we get? If you want to type it in, you can. Which one has the highest salary? Yeah, it's like 281, 155, 136, or 132. So the exponential is going to give him the best salary. A of t, yep, A of t. Calc. Joe. Who's Joe? Joe plans to build a rectangular garden with an area of 160 square feet. The length of the garden is 4 feet more than twice the width. Write an equation used to model and use it to determine the number of feet in the width. So we're going to like solve it algebraically and yada, 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 yada. To save money, she will use... Wait, hold on one sec. I forgot to... Okay, yeah. She plans to fence in her garden. To save money, she will use the side of her house as one of the longer sides. How much fencing does she need? Okay, so for any time we're doing like a question with... Let me get my stickies. Can you change the color of these? I like to draw a rectangle to give me an idea. So let's draw a rectangle. And let's go. We know the area is 160. I like to write that inside. And now we have to do some like let statement type stuff. It says the length of the garden is the length of the garden is 4 feet more than twice the width. So we want to use, let's say, X and Y. The trick with this is looking at which one comes at the end. The one that comes last or at the end, I know it's not literally at the end of the sentence, but you know what I mean. The one that comes at the end is going to be your, oh no, is going to be your plain variable. So X here is going to be my width. Now, can anyone write an expression to represent the length? And don't say Y. So using X, what would the length be? Good, Kira. 2X plus 4. Okay? So again, the trick here, because if you don't follow this, it can be confusing. Oh, which one is 2X plus 4? Which one, what's what here? Whatever comes last is your normal variable. Everyone know what I mean when I say normal variable. And then the other one is going to be in terms of that. 4 plus 2X, yeah, same thing. Okay. Now, how can we write an equation to model this? What's an equation that would model this scenario? You have to know how to find area of A. You could do something like that, Abram, but it's easier just to do it this way. Good. Area is length times width. So I could say, hey, width times length, doesn't matter the order, which one goes first or something, equals 160. And now we're going to solve it. Okay, length area equals length times width. So now when we solve it, what we're going to do is distribute, and what type of equation do we end up getting here? We get 2x squared plus 4x equals 160. What do we got? Got a quad. Yeah, we got a quad. All right, so the nice thing about quad word problems is they traditionally work out well. In other words, it's not going to be like her garden is radical 50 feet. It's going to be some integer, some whole number. So does anyone see a good first move? Good, 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 good. GCF. Don't start eyeglass factoring. GCF of 2. Throw it away. You don't need to hold on to it. Not precious. Throw away a 2. Now all of a sudden this is a sum product. So what adds up to 2 and multiplies to negative 80? What adds up to 2 and multiplies to negative 80? Good, good, good. We're on fire today. X plus 10, X minus 8. And we're going to reject the negative. The one on the left is negative. We can't have a measurement of negative 10. So the only answer we get is 8. What are the units here? 8 feet. I like to go to the let statements now. So if this is 8 feet, what would the length be? So 2 times 8, 16 plus 4, the length would be 20. So this garden is 8 by 20. 21. Wait, what happened? What did I miss? I messed up? Oh. Questions with that? We still have a follow-up to do, but questions with that? Questions with that? No? Okay. So this part's a little confusing. It says she's going to fence. So this is her garden. This rectangle was her garden, not her house. She's going to fence it in, but her garden is like against her house, let's say. So like this is her house. So in other words, she doesn't need fencing, obviously. Think about like, it's easier for us to say like backyard. Our backyards like touch our house. So like we don't have a fence right on against our house. So like we only have fencing. Most people like myself, you have like 3 sides fenced in, right? And maybe like a small gate in the front. But the side that's along your house doesn't have a fence. And I know that because it said the longer side. So I'm going to assume that this is the 20. She doesn't need like a fence there. What is this question? She will use the side of her house. How many feet of fencing does she need? Okay, so this is easy. C needs 20 plus 8 plus 8, 36. For part B, should be 36 feet. Again, it's basically asking the perimeter, but taking one of the sides away. So the perimeter would be 56, yes, but it's saying, hey, the side of her house is the long side, so she doesn't need that one dimension. There's a similar question. Okay. Yeah, that wasn't too bad. All right, factor completely. Why don't we copy and try 8? Factor and copy 8. Factor and copy. Copy and factor 8. When do we keep or get rid of? That's a good question, Kira. So, like, sometimes I say, like, throw it away. You don't really need it. If you're solving something, you don't really care about holding on to something because at the end of the day, you just care about the answer. If you're messing with an equation, so like a good example would be like when you convert something into vertex form, when you start moving things around, you're kind of preserving everything because at the end of the day, you want it to be an exact match. You don't want it to be like a similar version. Okay. So I guess a quick answer to that would be like if you're manipulating a specific function, you want to hold on to things. If you're just solving, you don't care. Like, all right, divide out of 2. All right, it's all gone. Divide out of 5, it's all gone. If you're working with like a function that you want to be an exact match, we want to more so preserve. Factor 8 completely. Yeah, Pop. Come here. Ugh. Say hi to everyone. You don't like Ryan? Okay. Okay, how are we doing? So anytime we see the words factor completely, we say kind of like be suspicious, right? Like why wouldn't I just say factor? So this implies like we're going to be factoring more than once. So how do we start here? Sometimes you have an option of like GCF and something else. You only have one option here. Yeah, there's only a GCF to start. There's a GCF of X. They both have an X in common. There's actually nothing else you could do here. Now, once you pull out a GCF, that opens up the doorway for something new because you have something new in the parentheses. So what is that something new here? Dots? Dots, yeah. So we're going to double bubble. I did this with 726 today, dots. We're going to take the square root. We put a plus and minus. Square root of 4x squared is 2x and 2x. Square root of 49 is 7 and 7. This is another example going back to Kira's question. It's not like we throw out the x here. Like the x is staying there. Okay? You should always be able to take a factored question and be able to get back to the original. Questions with that? I was told I go too fast when I ask for questions, so I'll take a pause. Any questions with that? Well, let's see. A lot of questions so far. Okay, no one ever asks questions. That's fine. Okay. And it's a lot easier when we're in person because people are just like, yo, I got something quick. And then you guys are all like shy or don't talk or anything when we're in a meet. All right, for number 9, solve for x to the nearest 10th. All right, so this is easier than it looks. Now, this is asking me to solve it to the nearest 10th. Hold on. Okay. Now, most people, if I said, what do we do first? Most people would say, box method, box it up. No, 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 no. What should you do first? Yeah, you could hit this with square roots right now. Why would you box it out? And then you're going to have to like, this is an ugly answer. You're going to have to end up doing CTS or quad formula and get right back here. So box it out. Use square root property. If all you see is something squared, you could use square roots. Square root of 5, we don't want to forget to do plus or minus. And now what? Yeah, this is basically like the end of CTS, not the last. Oh yeah, the last step. Yeah. Move the 1 over. Now, usually we would stop here, but the question did say nearest 10th. So just to practice with some calculator fluency, let's find the 2 solutions here. One where you're adding rad 5 and one where you're subtracting rad 5. There is no way to do it at the same time. Your calculator doesn't have a plus or minus button. So what do we get to the nearest 10th? We get, double check, 1.2 and negative 3.2. I guess the negative should go first. Negative 3.2 and 1.2. Okay, kind of easy one. Like if you did box it out, you only made it harder for yourself. And you're like, oh, I'm gonna do quad formula. This is so easy. You could have solved it in 1 move. Well, 2 moves, I guess. Okay, look out for square root property. Underutilized. Any questions with that? Questions with that? You have to type it in your calc. Yeah, you can't do this by hand. So -1 plus radical 5 and -1 minus radical 5. Yeah, you have to use a calc. Unless you want to take the square root of 5 somehow. Okay, we're good? Ooh, okay, I like this one. Is x minus 3 a factor of the polynomial? Justify your response. So what are they, first of all, what is this asking? It means when we say, is this a factor? It means like, is x minus 3 in there somewhere? Like if we do fully factor it, is x minus 3 one of the bubbles? So, yeah, okay. So there's a few ways we could do this, a few clever ways we could do this. One would be, let's just start with 4x squared, start messing with it and see what we get. Let's like factor ourselves and analyze if -3 is one of the factors. So what would you do first if I asked you to factor this? What would you do first? Yeah, don't eyeglass this. GCF of 4. Let's just hold on to it for now. -6. And now it's going to be a sum product. It should be a double bubble. What adds up to 1 and multiplies to -6? What adds up to 1 and multiplies to -6? 3 and -2. So is x minus 3 a factor? This isn't the answer, but is x minus 3 a factor? No, x plus 3 is a factor. Now this is a very clever or creative way you could have answered this as well. If x minus 3 is a factor, that means that 3 is a root. So this is first, what we did is perfectly fine. The answer is no, it's not, blah, blah. But this is a more creative way of doing it as well. If x minus 3 is a factor, that means that x equals 3, like makes that equation equal to 0. So what you could do is plug in a 3 and see if you get 0. So if you plug in a 3, you'll get 36 plus 12, 48 minus 24. You don't get a 0. So it wasn't a real root. Yeah, exactly. So kind of creative. Not many people would notice that or think of that, but that's a creative way of getting it. Yeah, justify means justify means show your work. So like, I know I wrote very informally here, but like this would be fine technically. Maybe write a little bit more like, no, it's not a factor. You don't need to explain, Jamil. Oh, okay, this one's good. So I said about every question. F of x and g of x, we're going to graph this system. So anytime we're graphing lines, if you printed it, you could do it right on the paper. If you have graph paper, you could do it as well. We have 2 linears, so this seems pretty easy. Suspicious. Okay, we're going to begin at 5. We're going to move up 3 over 1. Down 3, back 1, down 3, back 1, down 3, back 1. Now, when you're graphing a system, if you do have a system graphically, which odds are, if you looked at that analysis sheet, like there's a lot of system questions, you should have one somewhere. Not only we obviously have talked about labeling at great length, and someone unfortunately will still forget to label. Hopefully not. So we want to label right away. But you also want your lines to be like a little bit more exaggerated than usual. You're not sure where these are going to hit as you start graphing them, right? So in other words, I don't want to make my line like this, and then I'm like, oh wait, shoot, they hit. You know, I can see they're going to hit in quadrant 4 in the corner. I'm going to do my second line now, -4. And I'm moving. Ooh, and speak of the devil, I messed up. I'm going to move up 1 over 2. So I should have followed my own advice. I thought I did my line pretty long, but they end up hitting right in this far corner. So I'm going to go a few more points. Now, you don't even need to plot all these points. What you could do is simply like lay your ruler down on the 3 or 4 points you plotted, and then just trace them. Okay. So I see they hit. I'm not even going to go crazy with this line. I see they're hitting somewhere over here. And you might be saying, what the heck? Like, did I mess up? These aren't really, this isn't, I can't tell where that is. So I labeled them, but the problem here is that I can't see the solution. So now the follow-up here, and this gives it away a little bit, it says determine to the nearest 10th the value of x. So highlight that, star that, whatever, right? When I give my answer, I just want to say x equals, not a coordinate. That basically find the x value of the solution and explain how you arrive there. Now, I see Rachel and a few other people said calc. We could type this in. We could do our intersect thing if someone wants to go ahead and start doing that. What else could we do? What else could we do without using the calculator? Yeah, we could say, hey, where do you and you equal each other? Where do you guys equal? Algebraically, will give us that answer. We can't see it graphically. It's like somewhere, what is that even? 1, 2, 3, 4, somewhere between -4 and -5. Ethan, what are you writing, my man? So we set f of x and g of x equal to each other, and now we just solve. It's not even a quadratic or anything scary. It's a linear equation. Move the 1/2 over. 3 minus 1/2 is going to be 2.5 or 5/2. Move the 5 over, we get -9. How do we get rid of fractional coefficients? Reciprocal. So if it says 5 over 2, we multiply by 2 over 5. And that's going to be -18/5. I don't want to give that as an answer. It said nearest 10th. What would that be to the nearest 10th? Not a trick question. Yeah, you don't even have to round it. It's just -3.6. And we don't even usually say like, oh, plug that in to find the y value. What did the question ask? Just the x value. Just the x value. Just the x value. Is that it for my field test? Yeah. Any questions with the field test questions? We did everything. What I want to do is, did he just say have a god day and leave? Okay. Any questions with this first? Questions with the field test stuff? Because I want to stop sharing. We're not done yet. I want to, if you can hang around for a few minutes, I want to go over some calc stuff. So I'm going to share my calculator. This is like annoying to do, and I know I don't always do it during class. So. Okay, so I got my calculator. Hold on. That's right. Ryan, are you good? Okay, so, and I'll take some questions as well, if you could stick around. Let me just reset because I got some weird things going on here. Hold on. All right, so the first thing I want to do is, I think, well, let's do this. Let's go to y equals, and if you have a calculator, you want to follow along. I'm going to type in a quadratic. I'm just going to make it up. Hopefully this works out. Hold on, don't copy that yet. Let's make sure it works out. Okay, cool. So go back to y equals if you want to copy what I typed in. We're going to do a few things with this. So go ahead and copy what I typed in. Okay. Now, if you hit graph, we see a picture of this. Great. What I want to focus on is what we saw in class today, the idea of like how to find zeros. This was a little weird. So if you hit second trace, oops, second trace, it's option 2 for 0. Now, this was confusing, so listen. Listen. Left bound, right bound. This is, the calculator is very forgiving with a lot of things, like with intersect, you don't have to move at all and we'll find it. With this, it's not. So left bound means you have to be on the left-hand side of the root of where it hits the x-axis. So in this case, if I want the root on the left, being on the, like the root in the negative x-axis, if I want that root being left bound is actually underneath it, hit enter. Now it says right bound. Being right bound would be on the right-hand side or above the x-axis. It's hard to see, but those little like dotted lines should create a window where your root should now be between it. Yes, I don't even end up moving it. And you should get the root to be like negative 0.8 here. Okay? If I want the other root, second trace again, 0, you got to move the cursor. Now, left bound would actually be above the x-axis, the exact opposite of what we just said. It's hard to see because it gets steep, but do you see how we're on the left in regards to the root we're looking for? We're on the left-hand side. So hit enter. It doesn't matter, you know, how close or far you get. Now, right bound is below. I can go all the way down here if I wanted to, anywhere below the x-axis. See how the root, is it coming up in the meat? See those blue lines? The root is between those. If you mess that up, your calculator is going to say error or like nothing found. So when you do the left bound, right bound, you're creating the window that your calculator is going to look between. Are we following this? And now when we hit, you know, guess doesn't matter, you should get 2.1 as the next 0. Okay, a good skill, but it, like people get weirded out with it. They're like, oh, I forgot how to do that. I'm not going to use it. So it's a good thing to use. You could even use this to check a quadratic. Let's say, obviously, let's say you solved, you know, you did quad formula and you get 2 plus radical 3. Now your calculator is not going to say 2 plus or minus radical 3, but you could just do the conversion like, oh, that as a decimal is this. And then when I check it on my calculator, I get the same decimal. Does that make sense? So it won't give you like the nice radical form of it, but you could just easily convert it to a decimal and see that it matches. There wouldn't be a question where like you're required to know how to do this. They're not going to be like use the 0 function or else like you can't do this problem. But it's a good like it's a good tool to have. Good tool to have. Let's call it that. Okay. Cool. If we want as well, oops. Let me clear out the one we just did. The field test one, we'll go over the intersect feature. So 3x plus 5, I think we all know how to do this one. 3x plus 5, 1/2 x. It's a lazy way of typing 1/2. Minus 4, hit graph. See your 2 lines. Now for intersect, we hit second trace, choice 5. For intersect, you're supposed to go close to it, but technically it doesn't matter if they only intersect once. And then you just hit enter 3 times. Bop, bop, bop. And we get negative 3.6. Negative 3.6. As easy as that. Okay, that's it for me. Any questions? Andy's out. Miss Rice, if you can guess what I'm eating, you're eating a cucumber. I don't know. He was eating a cucumber during lunch today. All right, guys, have a great day. I'll see everyone tomorrow. Bye, devil. Pronounce Rice. Bye, guys.
Bye, Mr. Rice.
Bye, Ethan. Ooh, Ethan's going to be in the YouTube video because his camera's on and he just talked. Ethan's going to make a